Lesson 8.1 is inverse variation. Now, I believe we did do direct variation somewhere in first semester. I don't remember exactly where, but we did talk about direct variation, but we have not talked about inverse variation yet. So we're going to review direct variation. We're going to talk about inverse variation. And then when we get to the back page, which might not be till tomorrow, we're also going to talk about something called joint variation and what exactly that means. So, okay, direct variation. Direct variation, usually the phrase is x varies directly as y. Okay, or x varies directly with x varies directly with y. The equation you should be familiar with is right there. Y equals k times x, where k is a constant. So k is some number. We don't know what k is necessarily unless they tell us, but k is some number. And so we usually, with direct variation, we think about y equals k times x. And then we also, if you solve that for k, you solve that for k and divide the x over. In order to find k, we think about it as being y divided by x. And so those are the two formulas you'll want to be familiar with when we talk about direct variation. Now, inverse variation. Well, change one word, right? Instead of x varies directly with y, it's x varies inversely as y or with y. There's two equations I like to use. When you're asked to write an inverse variation equation, instead of y equals k times x, it's y equals k divided by x. So inverse variation has that division relationship, y equals k divided by x. And then if we're trying to find k, I like to use this one right here. In that if it's k divided by x, multiply the x over. So in order to find k, we do x times y. Now I believe, if you notice, there is a typo in this other one, because k divided by x equaling x cannot be true. I think which one's supposed to be, the denominator is supposed to be y there is what it's supposed to be. Okay, so that is x equals k divided by y. That can also be used with inverse variation. Now, that's the one we use the least. We just, we usually are looking for the one that is y equals to write the equation, or the one that's k equals so we can find k. So I would use one of the other two. And those are the ones you'll see me reference most. Okay? So, direct variation, it's y equals k times x. Inverse variation, it's y equals k divided by x. One of the first things we're going to do is we're going to, given a relationship of values, work on identifying, is it a direct variation? Is it an inverse variation? Or is it neither? Okay, it's some other random relationship that doesn't matter at this point. So, is the relationship a direct, inverse variation, or neither? And if it is direct or inverse, we're going to write the equation for it. We're going to write the, what do they use? Function model. Basically, when they're asking us for the equation, they're asking us to write, or excuse me, when they're asking us for the function model, they're asking us to write the equation. Now, how do we know if it's direct or inverse, or neither? Thoughts on what I can do here? Okay, I want to start with direct or inverse. Notice they give us x and y values, right? They give us x and y values. I think I'm going to start with inverse just because I like the math there better. But we need to test both. If it's inverse, what is the relationship for k? If it is truly an inverse relationship, x times y will always equal k. Okay? And in this case, are we given x and y values? We are, right? We're given x and y values. So take the first pair. My first x and y are 2 and 10. What is 2 times 10? 20. Okay, what's my next x and y? My next x and y are 4 and 8. What's 4 times 8? 32. Okay, I'm going to stop there. What does this tell me at this point? X times y equals k. They gave me two different k values. Well, if this is inverse variation, my k value is going to be the same every time. So at this point, I'm going to stop here on testing inverse, and I'm going to say, okay, this is not inverse variation, because x times y was giving me multiple different numbers. Now, let's do a similar thing for direct. What is the relationship supposed to be with direct? With direct variation, k is supposed to be y divided by x. So check that. Check and see if this is direct variation, y divided by x will always give me the same k value. So what's the first set? Y is 10 and x is 2. And what is 10 divided by 2? That's 5. What's the next set? 8 and 4. What's 8 divided by 4? 2. What did we just find out? I got two different k values when I was checking to see if it's direct. So it was not inverse variation. It is not direct variation. So what's that mean? This is an example of neither. It doesn't fit the direct variation mold. It doesn't fit the inverse variation mold. It is neither. Okay. So the idea, if it was inverse variation, all my xy's would have been multiplying to get the same k value. If it was direct variation, all my y divided by x's would have been dividing to get the same k value. And it didn't work there. Okay, let's try B. Thoughts on B? What do you want to try? You want to try inverse? So if it's inverse, x times y will equal k. So if it's inverse, right here, x times y will equal k. Well, the first set, 2 times 15. What is 2 times 15? 30. Okay, the next one, 4 times 7.5. Oh, 30? Okay. 10 times 3? 30. 15 times 2? 30. Oh, a little more successful that time? Okay, so because x times y always multiplied to be the same number, this is an example of inverse variation. Okay, as an example of inverse variation, what did we just find k to be? 30. We just found k to be 30, didn't we? What is a function model I could write to represent this? In other words, using x and y and 30. I heard multiple different things and I could not separate them out. Sorry, I tried. It did not happen. Someone volunteer again. What'd you say, Lorna?
Y equals 30.
I have to disagree with that one.
I said x, y equals 30.
Okay, so one option, and there are two options I could do. One option is that if k is 30, right, then xy equals k. And so xy equals 30. That's one option I can do. What's the other option here? If we're talking inverse variation, it's k divided by x. So if I take this formula right here and put 30 in for k, we could say y equals 30 divided by x.
I can do it.
Do what other way?
I can divide by y.
You could, traditionally though, we usually say y equals. Okay? Now, if you have to write a function model in MathXL, I can't remember exactly what MathXL requires. If you have to write a function model in MathXL, my thought would be they're going to want it to be y equals. And so if it's inverse variation right here, when you do y equals, it's k divided by x. If it was direct variation, that would be the y equals 30x, because that would be the y equals k times x. But with inverse, it's y equals k divided by x. Questions there? Did I answer all the questions I need to ask or answer? Okay. Some of you have moved on, I can tell. Okay, what are your thoughts on C? Do these values multiply or divide to be the same number? Have you grabbed the calculator if you need to? I know, decimals, right? What are you finding? Okay. Definitely not inverse, I agree, because they're not multiplying. If I do 0.2 times 8, I get 1.6. If I do 0.5 times 20, I get 10. So right off the bat, they're not multiplying to be the same number, so they're not inverse variation. Do they divide to be the same number? So what we want to check here is we're going to use this one. We're going to check and see, does y divided by x always give me the same k value? So if I try that, 8 divided by 0.2. What is 8 divided by 0.2? 40. Okay, no, y divided by x, so 20 divided by 0.5. What's 20 divided by 0.5? 40. 40 divided by 1.0. In other words, 40 divided by 1 is 40. And 60 divided by 1.5. What's 60 divided by 1.5? Oh, hey, it's 40 as well. So what's that tell me? Y divided by x. If y divides by x to give me the same value every time, this fits me into the direct variation. Okay. Direct variation. What is k? K is 40, right? So if you're asked what k is 40. What equations could I write to represent direct variation? Okay. One option is y equals, well, that was interesting. Y equals 40x. So that is my y equals kx, filling in k right there. So y equals 40x. The other option, I'm not a huge fan of this option. It's kind of weird to me, but you might use it. If it's y over x equals k, we could say y over x equals 40. And again, both of those work. I'm probably going to be more expecting y equals 40x, but I'll be honest, I won't count the other wrong. It is equivalent. What MathXL does is a whole nother story, right? Okay. You've seen one of each. What are your thoughts on D? I kind of start, and I'll be honest, what I do is I kind of jump around. Let's see, I don't know. If I don't know what 0.2 times 40 is, oh, hey, what about the bottom? Can I do 2 times 4? Or could I do 4 divided by 2 pretty easily? I can multiply and divide those numbers pretty easily, so what are we doing? Are we multiplying or dividing here? Multiplying. 2.0 times 4.0 is 8. 2 times 4 is 8. 1 times 8 is, oh, I start at the bottom. I see what you're saying. Sorry. I started with the easy mental math. 2 times 4 is 8. 1 times 8 is 8. 0.5 times 16. What's half of 16? That is 8. This is the one that you have to think a little harder for. 0.2 times 4. Or, excuse me, 40. That is also 8. So again, it fits into the x times y equals k. If x times y multiplied equal k, this is what type of variation? Inverse. Okay. Inverse variation where k is 8. What are options to write an inverse equation?
Y equals 8 times x. 8 divided by x equals y.
Okay. So, and I'm going to flip that around and say y equals 8 divided by x. Inverse variation is y equals k divided by x, so y equals 8 divided by x. If you use this form up here of more how did we get 8, it was always x times y, right? So x times y equals 8. Okay. Thoughts on E? If I multiply, half of 40 is 0.5 times 40. Half of 40 is 20. 1.2 times 12. Is 1.2 times 12 going to be 20?
14.
Yeah, I was going to say, what I see here is 12 times 12 with a decimal in there. And I know 12 times 12 is 144. So I know it's got to be some version of 144, and that's not going to work. What about dividing? Yeah, 40 divided by 0.5 is going to be what? 80? And 12 divided by 1.2 is going to be 10. It's not working, is it? So if my numbers aren't multiplying nor dividing, we're going to say neither. Okay. Questions there? Work to become familiar with those forms. What is direct variation and what is inverse variation? Okay. Let's go down to the next one. On this next one, suppose x and y vary how? Inversely. And x equals 4 and y equals 12. Okay, so we're told inverse, and we're given an x value and a y value. Three-part question here. First of all, what function models the inverse variation? Well, we just wrote function models up above, didn't we? In other words, an equation. What equation models the situation? In order to find an equation, what do I have to know?
X and Y.
Gives us it in the hint. We're going to have to find K. Okay, go back up to the top of your page. How do you find K in an inverse variation situation? What? X times Y, right? If you go back up to inverse variation, X, Y equals K. So because they want inverse variation, X times Y equals K. Do we know an X and a Y value? Yeah, those are provided, right? What's X? 4. What's Y? 12. So 4 times 12 equals K, and 4 times 12 is 48. So right there, K is 48. Write me an equation. What are my equation options you could give me for inverse variation based on the fact that K is 48? Okay, I think I heard both out there. One option, if it's xy equals K, we could say xy equals 48. The other option, what's the y equal option? It's y equals K divided by X. So y equals 48 divided by X. I'm going to go more for that one. Again, they're both correct, though. They're both equivalent. They're both correct. Okay, B. What does the graph of this function look like? Is this one we know off the tops of our head?
It looks like a top graph.
Do we know what y equals 48 divided by x looks like? I don't really expect you to know what that looks like. Okay. If we don't know what a graph looks like, what do I suggest? XY chart, right? Okay, so we're going to think XY chart. Now, we had two equations written up there, didn't we? We had the equation y equals 48 divided by x. Or we had the equation xy equals 48. You could technically use either equation. On this one, as I go to set up my XY chart, I don't know that I would do my typical 0, 1, 2. And the reason I say that is because you're not going to get a very good look. It's going to be hard to see the whole graph. Okay? So my recommendation, instead of doing your typical 0, 1, 2, I want you to think differently with me. XY equals 48. What relationship am I looking for there? If XY equals 48, two numbers that what? Multiply to be 48, yes? Give me two numbers that multiply to be 48.
4 and 12.
Okay. 4 and 12, is that it?
2 and 24.
2 and 24? Keep them coming.
3 and 16.
6 and 8, 3 and 16. I think you just forgot. I think there's
6.
6 and 8, or 8 and 6. I think the one you guys forgot to begin with is 1 and 48, and that's fine. I wasn't asking for them in order. I'm going to kind of go in order here because I kind of have a process I like to follow here. But if I go in order, 1 and 48 works, right? Then you guys, someone said 2 and 24, 3 and 16, 4 and 12. No one said 5 because 5 doesn't go. Are you guys noticing what I'm doing here? I'm going in order here, aren't I? So 4 doesn't go. 6 and 8. 7 doesn't go. 8.
B.
Okay. The same pair, however, is 8, 6 important to list? Or could it be? 6 and 8, 8 and 6 are the same numbers, but are they a different ordered pair? They are. So normally I would just say, okay, we've got all the pairs, right? Like when we talk about factoring and factoring into our 2 parentheses, I stop there. Well, here I'm going to keep going. So if 8, 6 is a pair.
So it's 12.
Oh, so is 12 and 4. I'm going to run out of room here. So is 16 and 3. So is 24 and 1. Oops, excuse me. Yeah, I caught it. 24 and 2. 48 and 1. That's a lot of pairs, isn't it? Now, if you notice here, we're going to adjust this to make it work for us. This XY chart only goes to 20, doesn't it? Okay. So, can we get the idea of the whole picture and leave off a couple of these ordered pairs? We can. I'm going to leave off when I'm graphing the 1 and 48 and the 2 and 24. Same thing with 24 and 2, 48 and 1. But going 3 to 16 and 16 to 3, going with those pairs, that'll still give me the shape of the graph, which is what I want you guys to see. Let's go ahead and graph this. So 3 and 16 takes me where? Right 3, up 16. Which, if you see those markings, you see 15, you can go 1 past that, right? 4, 12, right 4, up 12. 6, 8, right 6, up 8. 8, 6, right 8, up 6. 12, 4, right 12, up 4. 16, 3, right 16, up 3. Can you see if we did the 24s and the 48s, how they continue the pattern? Thoughts on what this graph is doing?
Curving.
Curving. Curving how? What's going to happen as this graph approaches the x-axis and the y-axis? Is it going to cross the x-axis and y-axis?
No, it's never going to touch.
It's never going to touch. Because in order to touch or cross the x-axis or y-axis, x or y would have to be 0. Could x or y be 0? No, because 0 times nothing will result in the number of 48. Now, what if I tell you we don't quite have all the possibilities yet? How else can we multiply to get 48? What'd you say?
-1, -48.
-1, -48. What happens? 2 positives multiply to be a positive, and how else do you multiply to be a positive? 2 negatives. Now, I'll be honest, I'm going to skip the 48s and the 24s this time. I'm going to go down to 3 and 16. If it was positive 3 times positive 16, we also need to think about -3, -16, -4, -12, negative 6, negative 8, negative 8, negative 6, negative 12, negative 4, negative 16, negative 3. Our graph was only set up for the first quadrant. And that's all right, I'm not going to be real specific on the other, but where do these negative ordered pairs fall? Quadrant 3. And here's what I'm going to do. If we were to extend our x-axis and y-axis, right? My current graph is in quadrant 1. Negative 3, negative 16 would take me left 3 down 16. We'd go left 4 down 12, left 6 down 8, left 8 down 6. You would have, can you visualize this? A similar graph that is reflected. And I'm not going to graph the specific numbers, but if I just graph the shape like that, does that give you the idea? The idea that there are two opposite curves. I have a curve in quadrant 1, and then I have to go to the diagonal quadrant to have the other curve. Okay? So inverse variation will always be those two opposing curves. In this case, it's in quadrant 1, so the opposing piece is in quadrant 3. And yes, we could have gotten specific with our number values here, but I figured you got the idea. Questions right there. Okay, we need to do C. Not sure where my time went. It went poof today. Thought I was going to get to my next example in the back, but let's just finish C. What is y when x equals 10? He randomly says 4.8. How is that not just random, but how is that how?
Because 4.8 times 10 is 48.
Okay, because 4.8 times 10 is 48. What did we need? We needed two numbers that multiplied to be 48, right? Or if you go back and use this equation right here, the equation we wrote up on part A was y equals 48 divided by x. Did they just give us an x value? They did. And so 48 divided by 10. And 48 divided by 10 is indeed 4.8. Okay. Well, I guess, since I don't have time to get into the backside, we will start with the other part of example 2 tomorrow. So we will work on that to begin class, and then we'll talk about our combined variations, basically direct variation, inverse variation, and joint variation. Math Excel should be available. I forgot to check, but this will make homework due on Thursday.